Hello, my name is Corbin Miller. This is take two because I had the wrong matrix for my first example. So the sections that I had difficulty with was 1.2, which was one of the very first ones that we did. That was with the row reduction. Um, it was fairly simple calculations. Just, the concept wasn't hard to grasp. It was just making silly mistakes, and that really kicked my butt. I did some of the practice problems and the handwrites. I had a very difficult time getting them right on my first try. That is, just because I'd rush through it, try and get it done, and make a silly mistake. The next section was 1.8, which is the matrix transformations, which is multiplying matrices. Multiplying matrices is probably my weakest point in this class. So the third section I had difficulty with was 2.1, which is matrix operations, which is very similar to 1.8, just a bit more complicated, with a few more columns in here to multiply by. And then the last section was 2.8, which is the subspace of matrices. So that's column space and null space, and the complications that I had with that section was just not understanding the concept at all. I really didn't know what I was looking for, and that made it extremely difficult. But once I realized that it was just finding which variables were basic and which ones were free, and then determining the basis for the column space or the null space off of that, and that really helped. That's probably my most improved section, because I read through it, took notes, did the practice video. I had no clue, and then something clicked. I think during the quiz, I was like, "Oh my gosh, this makes so much more sense," and I just flew through it after that. But so we'll get started on 1.2 here, which is the row reduction. So I'm sure you guys know how to do this, so it won't be too difficult. I drew all this out before because it's kind of painful drawing these. But the objective of this is to get zeros all under the first number in the first column, I guess, and then you're getting zeros all below it. So you kind of temporarily change the first row to be able to cancel out the rows below it. So the first one we'll do to cancel out the 6, we'll multiply R3 by -2. So how we write that is R2 prime, since R2, row 2 is one that we're changing, equals -2 times R1 plus R2. So we multiply our row 1 by -2, we get -6 in this first index, this first column, first row right here, and then you add those together, and that obviously cancels out. So first row is unchanged, so -2, 6, 3, 4. So we do 3 times -2, which is -6, add that to 6, which is 0. We do -2 times -2, which is +4. We add +4 to -4, which cancels out. And then -2 times 6 is -12. -12 plus -2 is -14. -2 times 3 is -6, plus 1 is -5. And then lastly, we do -2 times 4 is -8, plus 3, which is also -5. So that's the first row, or the second row, rather, done. We see a 0 under the 3 here, so we know we succeeded. So for the second row, so for for the third row, R3 prime equals, so in order to cancel out this -6, we need a +6. So 3 times 2, so 2 times row 1 plus row 3 will cancel out this -6. So 3 times 2 is 6, plus -6 is 0. -2 times 2 is -4, plus 4 is 0 as well. We do 6 times 2 is 12, and then 12 plus 16 is 28. Then we do 3 times 2, which is 6, plus 4 is 10, and then 4 times 2 is 8, 8 plus 2 is also 10. So now we have our 3 fixed, as we see a 0 right here. Under the 3 is all sorted out. So for the last row, so row 4 prime equals, so we need negative 9 to cancel out this positive 9, so we'll need to do 3 times negative 3. So negative 3 R1 plus R4, this will be 0, minus 2 times negative 3 is positive 6. Positive 6 plus minus 6 is 0. 6 times negative 3 is minus 18. Plus 4 is 14. Sorry, minus 14. 3 times negative 3 is minus 9. Plus 1 is minus 8. And then 4 times negative 3 is negative 12. Plus 1 is negative 11. So now to fix this, we have all zeros in here, so the next non-zero entry in the next row is minus 14. So now our objective is to clear out everything under this 14. So now that it's all handy-dandy, and these both are multiples of 14, it'll be fairly easy. So our 3 prime equals minus 14, we'll have to do that by minus 2. So minus 2. R2 plus R3 to cancel out row 3 right here. So row 1 will be unchanged. 6, 3, 4, 0, 0. Row 2 will also be unchanged. That's fine. 0, 0. So supposed to be a positive 2, actually, I'm sorry. Well, actually, yeah, it will be a positive 2. Sorry about that. So, minus 14 times 2 times positive 2 is minus 28. Minus 28 plus positive 28 is 0. Minus 5 times 2 is minus 10. Plus 10 is 0. And that's the same for the next column as well. So we do the same for row 4. So row 4 prime equals negative 1. I'm sorry, I zoned out there for a second. So we need negative 14 to cancel out. So we have to do negative 14 times negative 1 to give us 14. 14 plus negative 14 obviously will be 0. So negative 1 R2 plus R4, that'll give us 0 right here. Minus 5 times negative 1 is positive 5, plus minus 8 is negative 3, and then minus 5 times minus 1 is 5 again, and 5 plus minus 11 is minus 6. So for that, and since this is the last equation, this is the last kind of pivot, I guess you could say. We're done. This is the reduced row form of this first equation. So these two guys, this guy right here, this guy right here, are row equivalent. That's denoted by this tilde, tilde, something. I don't know how to pronounce it, but that's the row equivalent symbol. So we will come back to this and use this in a later example. So for 1.8, which is the matrix transformations, this is the multiplying. So, so we're finding AU. So we have A is this 3x2 matrix, and U is this 2x1 matrix. So these guys, so the resulting matrix, the product from these, will be a 3x1 matrix. So since A equals a 3x2 and U equals a 2x1, this and this number will be dragged into AU. So it'll be 3 by 1. And so if these second numbers were not the same, if they were not equal, we wouldn't be able to do this multiplication. So we'd have issues with vectors and columns and rows, and it just wouldn't add up right. So to begin, we can do, so we're going to find the first number right here in this first row. So it'll be 1, so it'll be this 1 times this 3. So 1 times 3, and we do that, plus 4 times negative 2. So plus 4 times negative 2. 4 times negative 2. So once we solve this, that'll be our first number. So for our second one, it'll be 2 times 3. 2 times, that's not 3, that's 6. 2 times 3 plus 6 times negative 2. Plus 6 times negative 2. Taking the second number in the second row and timesing that by the second row of U. For the third number, we will do the minus 2 times 3. Minus 2 times 3 plus this 3 times negative 2. Plus 3 times negative 2. So in order to reduce this down to the actual answer, we just solve these simple equations. So 1 times 3 is 3. 3 plus negative 8. 4 times negative 2 is negative 8. So 3 plus negative 8 is negative 5. The same for this. This will be 6. 6 right there. And times negative 12. So 6 plus negative 12. It will be negative 6. And then we'll do negative 2 times 3. It will be negative 6 as well. Plus 3 times negative 2. This will be negative 6. And we're adding these guys. So that'll be negative 12. So this equals AU. And we know this is AU. We can kind of check it to our what we estimated before. So we knew AU was going to be a 3 by 1 matrix, and it is as 3 rows and 1 column. So we do know it's a 3 by 1 matrix. So this is similar for 2.1. We'll get into that one in the next video.